All right, the next video is going to be on combining like terms because that's another skill that we need to remember and we need to practice a little bit before we start putting it into use pretty heavily with this. What combining like terms means is it means that when you've got a bunch of things together and you want to try and simplify them and combine them, you know which ones you can combine and you know which ones you can't combine. So a good example of this would be is if you were at a farmer's market and let's say you got a basket here and a basket here, right? And then somebody said, okay, well, we've got all these bananas over here, and then we've also got some apples here, and then supposing you have some pineapples, right? You got a couple pineapples, and somebody said, well, what I'd like to do is I'd like to have them all in their own separate containers, right? And so what you would do is you would say, okay, well, I'm gonna take my apples and I'm gonna put my apples all into this container over here, and then I'm gonna take my bananas, and my bananas are all gonna go over here, right? And then my pineapples, I'm gonna grab my pineapples and I'm gonna put those over here, right? So you'd say, okay, I have 2 pineapples and I have 4 apples and I have 4 bananas. So you went from having just kind of 10 pieces of fruit there to having 3 distinct things. So they're a lot more organized now. So that's kind of what combining like terms is like. So let's look at some examples of what it really looks like. So if you look at this one, you've got a term that has an x, you've got another term that has an x, right? So you've got 2 terms that have x's. When you have that, they are like terms because a like term with variables is any term that has the same variable with the same exponent. And with all the examples we're going to do, our exponent's always going to be 1. And of course, as we know, they don't write that down, right? So you'll see 6x, 2x. So the variables are the same. And because the variables are the same, that means we're just going to take that. And then you're going to have something that's going to be an x term. And you just add your coefficients. You go 6 and then plus 2 gives you 8, because this is saying that you have 6 groups of something, and we'll call each one of these somethings is an x, right? And then this is saying you have 2 more groups, and so all together you have 8 groups. This next problem down here, we've got 4x, and what I'm going to do is I'm going to use a specific grouping strategy with this where I'm going to box my variables. All right, so I've got positive 4x and I've got positive 9x. That means I got 4 groups of something, 9 groups of something. I add them up, I have 13 groups. Now you notice that I couldn't do that if these variables were different, but because this x and this x are the same thing, I can do it. And then what I'm left with is I'm left with this -7. So that -7 just kind of stays by itself and goes off on the outside like that. And then it's about as simplified as it can be. All right, let's look at another one. All right, and these start getting slightly more complicated as we go. So yellow is going to be for my variables. I've got positive 32, and then I've got -7p. So if I add 32 and -7, that is going to give me 25p. And then I will see if I have any constants to combine, and the only one I have is that -40. So this simplifies down to 25p minus 40. All right, this next one is kind of more what we're talking about and what you're going to see. So you got 5x over here, and then you've got positive 2x. So that gives you 7 of these, right? Because you got positive 5 and -2 of these. Then with your constants, I've got 15 and I've got -7. And notice I can't combine the 15 and the -7 and put them with the variables because they don't have a variable, right? These are just numbers. So the numbers can combine with each other. So you've got 15 and -7. That gives you positive 8. All right? Hopefully you're starting to kind of get the hang of this. All right, and this one right here, why don't you pause the video and try to solve this one on your own? Okay, so on this one right here, we're going to kind of play around with this, and let's start with our yellow, and yellow is going to be our x terms. So I'm going to go find all my x terms. I'm going to always take the sign to the left of it because I know I can combine that. And then I'm going to simplify that. So I have negative 4x and I have negative 6x, and so I'm going to add those two together, right? And so negative 4 plus negative 6 gives me negative 10x. Next thing we're going to do is we're going to do our y's. So I've got positive 16y. Remember, when it doesn't have a sign, it's always positive. And I got positive 13y. So 16 plus 13, these two right here, add up to be 29y. And then my last thing is I've got three constants left. I've got plus 8, plus 2 or positive 2, and I've got negative 6. So I just add them all up. I go 8 plus 2 is 10, and then 10 minus 6 is 4. So I have plus 4. So this is my simplified expression, right? Usually you go left to right, and you always put the ones with the variables first, and when you do the variables, if you have more than one variable, you use the variable that comes first in the alphabet. So you notice on this, I can't finish this up anymore. I can't add these two up and say, oh, well, that's going to be, 19xy. That's not how it works. They are not like terms. They have different variables because this x, sorry, wrong thing. This x I have here represents a different amount than this y, right? It represents something else. I don't know what it does represent, but I know it's probably not the same. Otherwise, they would both be called x. X is an unknown quantity for something, and y is also an unknown quantity, but they're different unknown quantities. So you need to remember that when you're doing combining like terms.